Hello guys, welcome back to another tutorial. Hit the bell icon button so that you don't miss out any tutorial.
My name is Matthew Raymer, and I'm looking forward to guiding you through the virtual jungle, which is an introduction to machine learning. Machine learning is, in part, based on a model of brain-cell interaction. The model was created in 1949 by Donald Hebe in a book titled The Organization of Behavior. The book presents Hebe's theories on neuron excitement and communication between neurons, synapses or synapsing. Hebe wrote, when one cell repeatedly assists in firing another, the axon of the first cell develops synaptic knobs or enlarges them if they already exist, which are in contact highway linked with the soma, the usefulness of the second cell. Transposing Hebe's concepts into an artificial neural network possessing artificial neurons, his model can be described this way. It represents an altering of relationships between artificial neurons, often called nodes, and encompasses also changes occurring in individual neurons. Their relationship strengthens when two neurons or nodes are activated simultaneously and weakens when they are activated asynchronously. The word weight is used to try to quantify these relationships. Nodes, or neurons, tend to match as paired positives or else as paired negatives. These matches are described as having strong positive weights. Those nodes tending to match as opposites develop strong negative weights. A plain analogy is like this. In the 1950s, Arthur Samuel of IBM developed a computer program for playing against itself checkers. This program had a very small amount of computer memory available. To offset this restriction, Samuel initiated what he called alpha-beta pruning. His design included a scoring function derived from varying positions and numbers of pieces on the board. This scoring function was an attempt to measure the odds of winning for each side. The program chose its next move using a minimax strategy, an idea which eventually evolved into the minimax algorithm. Samuel also designed a number of mechanisms allowing his program to become better playing against itself. In what Samuel called rote learning, his program recorded all positions it had already seen and combined this with the values of a reward function. In 1952, Arthur Samuel was the man who first came up with the phrase machine learning. Donald Hebe's model of brain cell interaction was combined with the machine learning efforts of Arthur Samuel, and so was created the perceptron. This was done in 1957 by Frank Rosenblatt at the Cornell Aeronautical Laboratory. The perceptron, oh, what a presumptuous name, had been constructed to perform image recognition. Although the perceptron seemed promising, it was unable to recognize many kinds of visual patterns, such as faces. The disappointment generated frustration and so helped stall further neural network research. Neural network or machine learning research struggled for decades until a resurgence arose during the 1990s. This said, there appeared in 1967 the new idea of the nearest neighbor algorithm. This algorithm idea represented the beginnings of basic pattern recognition. It was used in the mapping of routes. It solved the traveling salesperson's most pressing problem. One of the earliest algorithms, it found for salesmen the most efficient routes. Using it, a virtual salesperson enters a selected city and repeatedly has the program visit the nearest virtual cities until all have been visited. The method is clearly based on a simple idea of iterative deductive elimination. The credit for having invented the nearest neighbor rule has been given to Marcello Palillo. In return, he himself credited the famous cover and heart paper of 1967. In the 1960s, the invention and use of the concept of multilayers opened a new path in ML neural network research. It was discovered that a result could be obtained by providing and using two or more layers in the perceptron. Doing this offered disproportionately more processing power than a perceptron using one layer. Other versions of neural networks were created after newly modified perceptron opened the doors to layers in networks. Since then, the variety of ML neural network types has continued and continues to expand. The use of multiple layers led to the feed-forward ML neural networks and then to backpropagation. Backpropagation is an idea developed in the 1970s. It allows an ML network to adjust its hidden layers of neurons and nodes so that they adapt to new situations. It described as leveraging the backward propagation of errors. An erroneous output being processed and then distributed backward through the network's layers, where it is used to teach the program new correctives. Backpropagation is a concept now in use training ML deep neural networks. There has arisen since the ANN, or artificial neural network. This is hidden layers which are used to respond to more complicated tasks than the earlier perceptron was able to. ANNs are a primary tool type used in machine learning. ML neural networks use input and output layers and normally include a hidden layer or layers. Note, a hidden layer in an artificial neural network is a layer inserted in between input layers and output layers. By this means, artificial neurons take in a set of weighted inputs and produce an output by way of an activation function. It is a typical part of nearly any ML neural network in which engineers simulate the types of activities that go on in the human brain. These layers are designed to transform inputted data into a format of data that can be used by the output layer. The hidden layers are excellent for finding patterns too complex for a human programmer to detect. Effectively, this means that no human can find such a pattern and then teach the device to recognize it. In the 1970s and early 1980s, artificial intelligence research had focused on using logical, knowledge-based approaches rather than algorithms. Additionally, ML neural network research was pretty well abandoned by computer science and AI researchers. This caused a schism between artificial intelligence and machine learning. Until then, machine learning had been used as a training program for AI. The machine learning industry, which included a large number of researchers and technicians, was set on an alternative path. It was reorganized into a separate field and in this form struggled for nearly a decade. The industry's goal shifted from training for artificial intelligence to solving practical problems in terms of providing services. ML industry shifted some of its focus from the approaches inherited from AI research to methods and tactics used in probability theory and statistics. During this time, the ML industry maintained its focus on neural networks and then flourished in the 1990s. Most of this new success was facilitated by the growth of the Internet. This renaissance in research benefited from a fast and ever-growing availability of digital data. Ways arose which facilitated its sharing its newfound services by way of the Internet. I'll now describe certain advances that came out of the 1990s Renaissance for ML. One necessary development for the evolution of machine learning was the tool of boosting. Boosting algorithms are those used to reduce bias during supervised learning. They include ML algorithms that transform weak learners into strong ones. Note, I'll be talking in more detail about supervised learning in our next lesson. The concept of boosting was first presented in a 1990 paper titled The Strength of Weak Learnability by Robert Shapiro. In his paper, Shapiro states that a set of weak learners can create a single strong learner. Weak learners are defined as classifiers that are only slightly correlated with the true classification, although still more useful than mere random guesswork. By contrast, a strong learner is clearly classified and well aligned with true classification. Most boosting algorithms are a collection of repetitive learning weak classifiers, which are added in support of a final single strong classifier. After being added, they are normally weighted in ways that evaluate the accuracy of their weak learning capacities. Then the data weights are reweighted. Input data that is misclassified gains a higher weight, while data classified correctly loses weight. This environment allows future weak learners to focus more extensively on previous weak learners that were misclassified. The basic difference between various types of boosting algorithms lies in the technique used with them in weighting training data points. Currently, much of speech recognition training is being done by a deep learning technique known as long short-term memory, or LSTM. LSTM is an ML neural network model first described by Jürgen Schidhuber and Sepp Hochreiter in 1997. LSTM is able to learn tasks that require their execution memory of events that took place thousands of discrete steps earlier. With speech recognition, this is quite important. Around the year 2007, long short-term memory had advanced to outperforming the more traditionally used speech recognition programs. In 2015, and using a CTC-trained LSTM, the Google Speech Recognition program is reported to have taken a significant performance jump of 49%. In 2006, the Face Recognition Grand Challenge, a National Institute of Standards and Technology program, evaluated the popular face recognition algorithms of the time. 3D face scans, iris images, and high-resolution face images were all tested. Test findings suggested that the new algorithms were around 10 times more accurate than the facial recognition algorithms tested in 2002, and around 100 times more accurate than those available in 1995. Some of these 2006 algorithms were able to outperform human participants in recognizing faces and also could uniquely identify faces of identical twins. In 2012, Google's XLab developed an ML algorithm that was able to browse autonomously and find videos containing cats. Meow. In 2014, Facebook developed the tool known as Deep Face. Creepy sounding, I know. It is an algorithm capable of recognizing or verifying individuals in photographs to the same level of accuracy humans can.
Thank you for watching. Don't forget to subscribe to the channel. If you like the video, do give us a thumbs up and share it. Also check out amazing discounts and offers on our premium courses in the description below.